Hi, we're Team7. Our team members are Jim, Muskan, Stevie, and Zhiyang. Our project is the database application project. We aim to develop a management system for grocery stores. This system can cover all daily grocery requirements, such as the inventory monitor, customer service, and employee management. We're going to introduce the project overview, requirements and design, application details, task table, timeline, final deliverable, and also background material. For overview, our system is divided into three parts, one for database, one for middle layer, and also interface. Database part is responsible for data storing, and the middle layer part is for data cache. Interface is used for users' friendly interaction. We categorized our users into four parts. They are employee, store manager, customer, and vendor. And each part can divide it into four scenarios. For example, employee can be cashier, custodian, inventory manager, and store clerk.
Next up are the user queries for each of the roles that were just introduced by Ziyang. Starting with the employee role, the first query involves all employees who will want to be able to look up their shift schedules for each day. The next three queries are relevant to the custodian and inventory manager roles, with the custodian accessing maintenance records for different parts of the store, and then the inventory manager needing to check inventory as well as update the commodity thresholds for the automatic restock alerts. The store manager will want to be able to access employee records for specific dates and employees. As store managers are also responsible for campaigns, they will want to know which products have previously been part of a promotion. Then the next two queries are for pulling inventory orders as well as updating the store budgets. The next role is the customer, and as the customer, their queries will revolve around making an account, setting up a subscription, searching through the inventory catalog, and looking back at their order history. Finally, the vendor will need to be able to access and update their contracts with different stores, track all of the shipments by product and by date, as well as check their own inventory. Moving forward, the next two slides capture the ERD database design. These slides highlight the key components and relationships of the ERD for each role. First up is the employee entity set. That is the parent entity of a hierarchy, which has each employee role as a child entity. The four roles all inherit the employee attributes, which include SSN, name, and birthday. Below the role icons are an example of the relationship sets specific to the employee role. The cashier is assigned to a cash desk. The custodian maintains the maintenance records. The inventory clerk receives inventory alerts, and the stock clerk restocks the shelves. For the store manager, the arrows represent both a participation and key constraint, as the store manager manages exactly one store, and each store is managed by exactly one manager. The other main entity sets that have a relationship set with the store manager are budget, shift schedule, campaign, and inventory orders. Continuing to the next two roles, the customer also is a hierarchy to capture the two types of customers, members and non-members. Now the parent entity still has a relationship set with the shopping cart and returns entities because these functions are still available for all customers. As for the members, their membership comes with access to notifications, subscriptions, and personal meal plan recommendations, requiring a relationship set with each of these entities. Lastly, there is a vendor entity set that has a ternary relationship with the store order and store manager entities. The relationship set is called sends and processes because the store manager sends an inventory order for a list of products that is then processed and shipped back by the vendor. Now Muskan will take you through the product details.
Thank you, James. I'm Muskan, and I'm going to be explaining the product details. So we have the three major product details, which includes all the inputs and outputs for our grocery database management system. Firstly, we have the inventory tracker. A well-managed inventory is crucial for both stores and customers, and our inventory tracker ensures real-time stock monitoring. Store managers receive instant updates on stock levels, reducing the risk of shortages and overstocking. Automated restock alerts help streamline supply chain operations, ensuring essential items are always available. Customers benefit from accurate item availability, preventing frustration from out of stock products. Next up, we have the shipment coordination. To keep the supply chain running smoothly, our system integrates a shipment coordination process. It manages supplier deliveries through the vendor side, ensuring timely restocking of essential products, tracks order fulfillment status, reducing errors and improving overall efficiency. And thirdly, it enables better scheduling for shipments, helping businesses cut down on delays and optimize logistics. Next up, we have user recommendations, which is one of the most important features of our system. And through this, we can generate personalized meal plan recommendations. So it tailors meal suggestions based on user preferences, dietary needs, and budget constraints. This feature helps customers save time on meal planning and encourages healthier, cost-effective choices. By analyzing past purchases and nutritional data, the system adapts to the changing user habits and continuously refines the recommendations for the user. So next up, I'm going to be explaining the test cases. So these are some of the few examples of the test cases that we have. The first one being place delivery order. So the input that we take are the commodity, quantity, and the vendor. And then the expected output would be order placed. Please select different vendor, and so on. Similarly, for setup subscription, the inputs are commodity and frequency, and the outputs are subscription set or specifying the frequency. Thirdly, we have the recommend meals test case, and the inputs for that are preferences, order history, and the expected output would be the meal recommended to the user. And the programming tools that we are using for our database are Python for developing the logic of the code, SQL Oracle database for managing the backend, and we're using Flask, HTML, CSS, and JavaScript for the front end. Now, Steffi will take you further in the presentation.
Thank you, Muskan. Now let's take a look at our task table, which outlines the key milestones of our project and helps us stay organized. The following features are central to our system's development. Firstly, the recommendation engine, which suggests meal plans based on user preferences, dietary restrictions, and past behavior to enhance the shopping experience. Secondly, the inventory alerts, which notifies users when stock levels are low for frequently purchased items, ensuring product availability and informed purchasing decisions. Next, we have the customer review system, which collects user ratings and reviews to improve products and create a better shopping environment. And finally, the member notifications, which engages users with targeted promotions, sales, and updates on new products to keep them informed and engaged. These features aim to make the online grocery shopping experience more personalized, efficient, and user-friendly. Now let's take a look at our project timeline. So we have a clear timeline here for each stage of development. The last month, we focused on designing the database schema, like converting the ERD to DDL and debugging any system issues that we had. In this month, we are prioritizing query optimization, user interface development, and beginning testing to ensure core functionality. The next month, we will be finalizing the system, conducting comprehensive testing, and preparing for project submission. This structured timeline ensures steady progress and on-time completion, with each phase building on the last to address issues early and refine the system. To address our system's performance, we have come up with 3 key evaluation criteria The first one is test case results, like conducting unit and integration tests to verify system functionality. The second one is query efficiency, like measuring database performance to ensure fast response times and prevent delays for users. And finally, the user experience, like evaluating the ease of navigation, accessibility, and responsiveness of the user interface across devices. These criteria will guide improvements and ensure the system delivers an optimal user experience. For our reference, we have compiled a set of background materials. We have listed a few here, but we do have a lot mentioned in our project proposal. These sources provide valuable insights that helped shape our project. That concludes our presentation. Thank you for your time, and we look forward for your feedback and any questions that you may have. We are happy to answer it. Thank you.